Hi guys, my name is Peter C. Dogba Jr., math instructor at the University of Liberia and your math tutor. In my today's lecture, I will be discussing differential equation. And under differential equation, I will be particularly looking at formation of differential equation. So how do we formulate differential equation? So we'll be considering few rules. We say rules to form differential equation from a given equation in x and y containing arbitrary constants. So if we have a differential equation that contains arbitrary constant, how do we go about, let's say we have a given equation now, not a differential equation, that contains, arbitrary constants. How do we get rid of those arbitrary constants and derive at the differential equation? So the first rule says that we must write down the given equation. So whatever equation that is given to you, even if the equation is not given to you, you must derive the equation and be able to write down the equation. Step one. Step two says differentiate with respect to x successively and as many times as the number of arbitrary constants. So if there is just one arbitrary constant, you must differentiate once. It means the differential equation is going to be a first order differential equation. If there are two arbitrary constants, it means you must differentiate twice because the differential equation will be a second order differential equation and so forth. So if there are three arbitrary constants, there are four arbitrary constants, that's how you continue to work. And then the last rule says that we must eliminate the arbitrary constants. So sometimes the elimination process of the arbitrary constant is where now we must apply some, algebraic simplification, some manipulation to be able to solve for the arbitrary constants. So we look at different types of methods in how we can eliminate the arbitrary constants after we have done the required number of differentiation that we should be doing in a given problem. So we said the resulting equation is the required dE. The first question says that find the dE of the family of lines passing through the origin. So what do we call family of lines? Family of lines are lines that are related in one or two ways. Either they have the same slope or they have the same intercept. So we have, assuming that you have this diagram, and this is the this is the y-axis, this is the x-axis. So we have these lines that are running through the center of the cycle. All of them are running through the center of the cycle. All these lines are running through the center of the, all of the lines are running through the center of the cycle. And so many of them. So all of these lines are running through the center of the cycle. Now we know that the general equation for a straight line is y equals mx plus b. So this is our step one. So there's our step one. Write down the equation. So we have derived the equation from the graph, and then we've written down the equation. But one thing we need to take notice of, since these lines now are not running any other area, but they are all running through the center of the cycle, it means that we do not have a value for b, or we can say b is equals to 0. Now, why is it that b is equal to 0? Because there's something called the y-intercept. The y-intercept is the form where x is equal to 0 and y is equal to some value b other than 0. So if the lines are all passing through the center of the cycle, it means at this point x is equal to 0 and y is also equal to 0. So because of that, now our b now will be equal to 0. So we have the new equation, y equals to mx So there's the first step. We've written the equation. The next step says that we must differentiate with respect to x successively as many times as the number of arbitrary constants. So now we have an arbitrary constant here called m, or we call it the parameter. Now, since there's only one arbitrary constant, we must differentiate once. So we say y prime, we are differentiating now. The derivative of mx is just m. Because the power here is 1, if you subtract, you bring this 1 down and subtract 1 from this 1, you left with x to the 0 power. X to the 0 power is 1. So it's just m times 1. So there's the derivative m. But m, which is the arbitrary constant, had not been eliminated. M still within the problem. So we know from the original equation, which is y equals to mx, we know that we can solve for m, thereby dividing both sides by x. So m will be equal to y over x. So if m is equal to y over x, now we can substitute. So we have y prime to be equal to, this m now is y over x. So this is our differential equation. So there are several other ways that you wish to write the differential equation, the final answer. So you can decide to leave it like this, or you can decide to say, I will change this y prime to dy by dx and maintain it like this. Another way you could say, okay, I'm not going to do it like this. I'm going to multiply this x by this differential notation. So I can say x dy by dx all equals to y. So there's another form. Or I could say, let me cross multiply. From where, let me cross multiply. Dy times x is x dy equals dy times dx times y is y dx. So I could leave it like this, or another person could say, no, I want to put everything on one side of the equation. So it's x dy now minus y dx is equal to 0. So several other ways you can write, your final answer of the differential equation. So this is actually what we refer to as the required differential equation for this equation that was given from the beginning. So thanks ever so much for watching. See you in our next video.